Hello and welcome. I'd like to acknowledge the custodians of this land, the Gadigal people of the Eora Nation and their elders past and present. We acknowledge and respect their continuing culture and the contribution they make to the life of the city and the region. So thanks everybody for joining us today. This is the 28th Sydney NLP meetup. My name is Ben Hachey. I'm head of applied AI at Harrison and one of your hosts. Stephen Hogg is head of AI systems, also at Harrison AI, and the other host of this event. And Stephen will also be facilitating the live Q&A after Kellie's talk today. But let's get to the main event. So I'm really happy to introduce Kellie Webster today to talk about the really cool work she's doing on translation work on translating gendered pronouns. So Kellie is a software engineer at Google in New York, where she works on discourse level, coreference modeling, and ML fairness. She did her PhD at the University of Sydney using cognitive insights for coreference resolution, where she was ridiculously well organized and productive. Just one of those people. Her undergraduate degree in maths and linguistics are also from Sydney. So yeah, just your sort of typical blissed out Sydney beach bum. Kellie developed and ran the Gendered Pronoun Resolution Challenge in 2018. I believe that's a public data set as well, Kellie, right? So people can check that out on Kaggle and have a play with that data as well. Kellie also founded and organizes the workshop series on gender bias in NLP, which I think you can attend virtually as part of Calling next week.
That's correct.
That's correct, yeah.
ACL next year. So.
And ACL next year, cool, yeah. Just sort of relating Kellie's talk to the other talks that we've had this year. So the 3 online talks since COVID, I'd like to think that they bring our meetup back to its roots a little bit, focusing on the relationships between humans, language, and technology, which was the original name of the Sydney NLP meetup. So we had Rob Monroe first, who talked about human in the loop machine learning. And then we had Johannes Hofart, who talked about machine in the loop tools to amplify human intelligence. And today, Kellie rounds out the series by talking about a particular challenge in NLP that can adversely affect or adversely impact people, as well as a technical solution to balance that effect. So the presentation today is pre-recorded, so we'll stream it to you. There are a couple of points where we'll stop so that you can ask Kellie questions during the talk, and then we have a bit of time at the end as well. But the pre-recorded bit is about 45 minutes. Kellie, of course, you can see her is live on the Zoom. So she'll be, during the talk, she'll be answering questions in the Zoom chat, and at the pause points, she'll be able to answer questions by video as well. In the video, Kellie is joined by Melvin Johnson, also from Google. And I wanted, Kellie, if you want to say a little bit to introduce Melvin as well, because I don't think he's here to answer questions today, but he is in the video, right?
Yeah, so thanks, Ben. That was a great introduction. I was remembering some things that I've done in the past while you were reading them out. Melvin's been just a fantastic collaborator. I started working with him when I was living in California. He's very senior in the research in Translate team. So a lot of, if you read a lot of the publications from Google Translate, it's got Melvin as a key contributor there. And he was just so great in this process, understanding what the challenges were in Translate that needed research. So he supported my research that's presented in this, and also he gives some context in the pre-recorded session about the product and why we picked this research direction.
Without further ado, live from New York, it's not Saturday night, but anyway, over to Kellie Webster to talk about translating gendered pronouns.
So this talk is really looking at Google Translate. It's a bit of an overview about issues we see and some of our ideas about how to address them.
Yeah.
Okay.
Yeah, so I mean, just a brief introduction. The first sort of MT demonstration was in 1954, a collaboration between Georgetown and IBM. They had 250 rules and a bunch of grammar rules. It was a rule-based MT system. And since then, we've actually come a long way. So if you go to the next slide, Kelly, we have neural machine translation today. You all might have seen these announcements from these big companies. So there's the announcement from Google. We had this paper on NMT in 2016. Microsoft in 2018 had this announcement of achieving human parity on the news translation sentence level task. If you go to the next slide, Kelly. So just talking about Google Translate, Google Translate was actually launched in 2006 at Google. It was founded by 2 engineers who were doing this as their 20% project, as their part-time project. And then they hired a bunch of experts and built it into a big team. So since 2006, we've actually grown a lot. So currently we translate about 30 trillion sentences per year, and we support 108 languages. And we estimate that we have about 1 billion monthly active users. It's just an estimation because we actually don't require people to sign in to use Google Translate. It's a free app, so you can just go to translate.google.com and you don't have to sign in. You can just start translating, right? So we don't have a perfect estimate of the number of users, but our estimate is that we have about 1 billion monthly active users. So it is a big product. It's used by a lot of people. It's available both on the website, translate.google.com, and on your phones, right? You can have the apps on Android or iOS. Next slide, Kelly. So one thing that's happened over the past few years is sentence level translation quality has been improving. And I alluded to this in the Microsoft announcement, right? They say they achieved human parity on the sentence level translation task. So as you can see, we have some of our high resource language pairs here. And here we're trying to do an evaluation of the machine translation output and the human translation. And we get these ratings, right? So on the left, we have the single-sided presentation where we show both the systems independently to raters and we get the ratings. So you can see on some languages, the amount of human perfect and MT for perfect is pretty close. Some languages, MT perfect is even higher. And most cases, they're all acceptable, right? So if you look at it, there's not a big difference between the human and the MT system. On the right-hand side, we have the same evaluation, but done in a side-by-side setup. So the raters see the source, they see the base systems translation, and they see the test systems translation. So this is a different form of rating. Again, the story is pretty similar. So you have a chunk at the top where MT is better, you have a chunk at the bottom where human is better, and then a big chunk in the middle where both of them are the same. And it's very competitive, at least on this single sentence translation task. But if you go to the next slide, Kelly, we're far from being done, right? So there's a lot of bias issues in AI, and machine translation is very much included in that. So you see this article from Fast Company from 2015. It says Google translates gender problem and Bing translates and cis-trans. So a lot of these machine translation engines have bias, and they amplify societal bias through the translations that they offer. Next slide, Kelly. Yeah, so when we're thinking about bias, gender bias is one of the biggest challenges for Translate. And you might have definitely seen this screenshot of Turkish to English translation where Obir doctor becomes he is a doctor and Obir hemsayer becomes she is a nurse. So the Turkish pronoun O is gender neutral. So that means that it can translate to he, she, or it, depending on the context. And in this case, when we're doing the translation independent of the context, we're picking he to be the masculine pronoun for doctor and the feminine pronoun for nurse. So we're essentially exhibiting bias through this. At the bottom, you see another screenshot, the same thing going from English to Spanish now. So I talk to my doctor, it gets translated to the masculine form of doctor. I talk to my secretary, it gets translated to the feminine form of the secretary. So again, we don't give the model any context. It's a single sentence task, and the model decides to pick masculine for doctor and feminine for secretary. So when we take a step back and think about this gender problem, right? What is the right thing to do in this scenario? So if an ambiguous gender must be resolved for linguistic reasons, should we let the training data vote? So that was the current behavior, and obviously it was not satisfactory because the training data is biased, right? Should we flip a coin? That seems much harder than it sounds. So one of the things is if we always flipped a coin and we showed either the masculine or the feminine, we still have the possibility of showing biased results to certain people. So the perception of bias will still be there, right? So that's not the right solution. Should we adopt gender neutral novelties? So in English, there's the singular they. So instead of saying he is a doctor, you can say they are a doctor. We have some slides at the end that will talk about this, but again, we're not sure whether this met the needs of our users. So the final thing that we ended up doing is wherever possible, we tried to change the task. So instead of showing one right translation, we tried to offer multiple translations with an explanation. Or can we give the users the control? So we show them the masculine translation and we give them the control that says, hey, if you want the feminine, press this button and we can change it to feminine. So something like that. And we felt that this was the right thing to do for the gender problem. So we did end up changing the task. So this is what we used to do before. And you see on the right, the screenshot of our launch. So from Turkish to English, now we actually show two translations. When we realize that the source is ambiguous, we show a feminine translation and a masculine translation, and we mark which one's which. So now a user gets both these options. Next slide. Yeah, so these are some announcements that that we made, publicly. Some blog posts if you want to read more about it. We've actually sort of updated the approach to make it more scalable in recent times. So if you have any questions on this, I'm happy to answer them now or later. But let's move on, Kelly, maybe in the next slide. So what we did end up launching is for single words, right? When we go from English to 4 other languages, I think Spanish is one, German, Italian, and Portuguese, I believe. We show these options. So this is relatively easy. So what we need to do is, okay, we have a single word on the source. Let's ingest the dictionary, which has both masculine and feminine information, and we show both the alternatives. So nurse, we show enfermera and enfermero, both the feminine and the masculine versions. And then for the sentence level task, Kelly, if you go to the next slide, yeah. We initially launched this for Turkish to English. So when someone types in an ambiguous sentence on the source in Turkish, we show both masculine and feminine options. And since then, we've actually launched this for a few more language pairs. So we now support Finnish to English, Hungarian to English, and Persian to English. So all of these languages have one thing in common. They're actually ambiguous on the source, and they have these ambiguous pronouns. So because they have these ambiguous pronouns, the bias that we display is very prominent because the model has to pick a gender, right? So for all of these ambiguous source languages, we now show 2 options. Whenever someone types in an ambiguous sentence, we will give them 2 options. Next slide, Kelly. So moving along from going from sentences to documents, right? So let's look at this Spanish sentence, and then let's look at the translation. And the translation says, he led an unconventional life. And when you actually read the Spanish sentence, this seems like a really good translation for that Spanish sentence. But when you take it in context, this is actually a bad translation, because this sentence is picked out from the Wikipedia page for Frida Kahlo, and the right translation should be "she led an unconventional life." If we go to the next slide, yes. So when we tried to translate that Wikipedia Spanish page into English using Google Translate, this is what we get, right? So we have some feminine pronouns, but a bunch of masculine references. So that he led an unconventional life around his biography and his own suffering. So about 3 out of 10 personal pronouns are wrong. So these are actually pretty severe errors in translation, right? But when we measure blue score, they're not picked up. Or when we do human evaluations at the sentence level, they're not picked up, right? So we really have to do document level evaluation to surface these errors. And actually, more recently, one of the things that we've been finding is, even if we did document level evaluations, raters actually don't penalize the translation system for producing masculine pronouns as much as we would have liked. So they might give the feminine one 10 out of 10, and they might give the masculine mistake 9 out of 10, right? But if you ask me, they should give it a 2 out of 10. But again, there's this notion of rater bias as well when we're rating these translations. So these are severe, but they're not picked up easily by standard evaluation. Next slide, Kelly. It's even worse when you look at some other Wikipedia pages. So this is the Wikipedia page for Marie Curie. It's been translated from Spanish to English. About 16 out of the 20 pronouns are wrong. This is pretty bad when someone's looking at this page. Next slide, Kelly. Yeah, so some more examples with Britney Spears, a bunch of masculine pronouns. So recently, thanks to Kelly's work, we've actually tried to improve exactly this phenomenon. So if, when Kelly goes to the next slide. So this is what we get now that you put in Britney Spears' Wikipedia page. We now are able to detect that the entity that's being spoken about is feminine, and we now have the right feminine pronouns. And Kelly is going to talk about the research that she's done that went into this, that enabled us to launch this feature.
Yeah, so I was really excited that this launched. This was research that I did a couple of years back now, and you'll see some dated references to different NLP technologies in my talk. But the talk that I prepared is based on this paper that we have up on Archive, which was the research work behind improving Spanish to English in particular for this work, but also the basis of other languages to English, where you have ambiguous pronouns in the Spanish side, and English requires you to resolve those. So for completeness, I'll just walk through what the problem is, although I'm sure people in this room are the experts, not me, on Spanish and Spanish pronouns. Third person singular pronouns in English are gendered, so we have in the subject position he and she, and in the possessives we have his and her, but both his and her are translated with the same Spanish pronoun su. And while there are equivalents of he and she in Spanish, these are often dropped when you can infer which one should be used from context. So if you just look at the surface form of a Spanish sentence, often you don't have the necessary information within that particular sentence to produce a full English sentence. So the second one here, apologies to the Spanish audience for my terrible Spanish accent, adquiere fama durante su niñez, could either be he or she acquired fame in his or her childhood. There's no inflection for gender there, and it would be valid for a translation system to produce either his form or the her form. I've got another sentence, the top one there, that I won't try to pronounce, that does have some gender information within the sentence. So we have desde niña. You've got a feminine form, so you could use a sentence level translation system here to produce she started to act, and that's why some of Melbourne's translations were correct and some weren't. So the sorts of problems that my paper looked at was when sentence level context isn't enough. There isn't information within a sentence to tell you whether to use a he form or a she form. You really need to look at the context beyond that single sentence to understand who's being referred to. So these are my research questions. The first one is, we want to reduce the number of errors we make in translation, particularly on the case of pronoun gender, since, as Melvin noted, it's particularly egregious. It can be quite jarring, and some people may interpret it as like reflecting social bias, and I think that's valid to do that. The approach that we looked at in the paper to reduce the number of errors on pronoun gender was to build a classifier that takes a sentence in context and it produces gender tags that give the translation system some hint about what pronoun to use. So that opens the second research question of how do we build such a classifier. And here's my dated reference in NLP that we need large amounts of data. This was before the few short learning of BERT and other huge language models became the flavor of the day. So we have the third research questions of how do we gather a huge amount of labeled data for how to translate these Spanish sentences in context. And I'll address that one first and walk through how we generated the data that we needed, then how it was used to build a classifier, and then its impact on end-to-end machine translation. So first to the data. The particular goal that we had when building the data pipeline was to gather as much labeled data as possible, but we wanted to do it at scale. We wanted to produce thousands of examples, not hundreds of examples. We didn't, and we wanted to do it as cheaply as possible. I actually developed a completely automatic method that didn't require any human annotation for this. So the format of the data that we wanted to have a sentence in context. I'm pointing to one that's too small to read, but there's a verb publico here that doesn't have a subject in Spanish, and we wanted to be able to put a gender tag on it like feminine to give a translation system a hint that this is the subject of publico. Who did the publishing was this Mitsuko, and Mitsuko, we know from context, identifies with female gender and should have female pronouns in English. To gather this data, I use Wikipedia exclusively, and I took advantage of the fact that English and Spanish Wikipedia looks very, very similar. If you kind of squint your eyes, the structure is similar, the content is similar between the two. And I did a 3-step pipeline to take advantage of this fact that there's such strong alignment between Spanish and English Wikipedia to generate these gender tags. So the first alignment step is to align articles. At all stages in my pipeline, I opted for a high precision heuristic. And so for aligning Spanish and English pages, I only accepted pages that had an exact match in title between Spanish and English. So this first step yielded document pairs where one is in Spanish and one is in English, and the expectation is the English is not a like a WMT kind of alignment. It's just a fuzzy alignment that they should be roughly similar. Within the articles, I broke the articles down into sentences, and the goal was to align sentences that talked about similar content. So like in the English, we would have like a sentence like she published something, and in the Spanish we had publicó something. And we wanted to do this bipart type matching. Again, we opted for high precision and did that using the existing translation system. So for the English side, we translated the English into Spanish, and on the Spanish side, we translated it into English. And then we looked at overlap between the two English sentences and the two Spanish sentences. And if that was above a threshold, we said that these two sentences were aligned. And once we had alignment between sentences, often they were almost exact translations of one another. But what we actually did was something like fast align. We just did token level alignments. And if we aligned published to publicó, and in English published had a she, we put a tag on the Spanish that says that publicó should be translated with a she pronoun based on what we know from the English side. So yeah, none of this required any human in the loop. You can run at scale across any language that has Wikipedia. It's better in higher resource languages which have large Wikipedias like English, like Spanish. But we've also looked at doing different Wikipedias, and this is a really promising technique for getting information from the English dispersed through the others. As I said, I did this in a really, really high precision way. I opted to throw away near alignments if I thought it might introduce noise. So we've got this kind of funnel shape distribution when we look at how many articles we used. When I scraped Spanish Wikipedia, it had over 1 million articles. And then if you only consider exact matching titles, I only look to extract sentence pairs from 400,000. Obviously, if you take into account different accents and different mappings of articles, you could get more. But from the 400,000 articles, about 10% of them had at least one sentence with this like very, very close translation match into English. And in those 40,000 articles, there was roughly 4 sentences like this. So we considered 160,000 examples to be really high, and we didn't need to kind of push back and get recall through this pipeline. All the data in these slides and in the archive paper is based on these tens of thousands of examples. Like we see typically in Wikipedia, there's more of one gender than the other. So in this, for every 4 examples, roughly 3 would be masculine and 1 feminine. And to build our final test sets, we downsampled the masculine. So we ended up with 1-to-1 feminine to masculine. So yeah, we consider this to be a big success. Like it was a bit elusive at the time that I did this work about how to get data sets of this size with labels. Like there was not very much aligned data for this task. And it was considered that you would need to get a human translator to be able to like translate passages to be able to get the sort of data that I was getting for free just by aligning Wikipedia in clever ways. So this part of the talk is about can we learn what is tagged up in this task? And the TLDR is yes, we can. This was a couple of years ago, and the classifier that we was successful in getting to learn this task was a fine-tuned BERT model. But for analysis and interest, I'm just going to walk through a series of baselines and show how well you can do on pronoun translation when you have different settings. So all the results that I'll show, I've disaggregated. So the data pipeline does alignments and tags for both pro-drop when a subject pronoun in Spanish is left out, and for possessives, which could mean his or her. And I've separated out the two genders to understand if they have different performance. The first baselines that I'll show are two MT systems. The MT system that I call baseline is a sentence level system where in training you just give it a single sentence, you show it a single sentence and you need to produce a single sentence output. I trained a special model that was called context MT, so you show the machine translation system two sentences of context and you need to produce a single output, but hopefully the context and the extra information helps you to produce that sentence better. So these are the numbers. So baseline MT was the sentence level model. The context annotation, so like the second row there is like you show a sentence level MT model, multiple sentences, you get multiple sentences out and you score the last one of those. So baseline MT a few years back did quite poorly on the feminine case, so it had really good precision, but its recall was low, so it wasn't producing she and her pronouns very much, but when it was, they were correct. This was, not so surprising to people who have used Google Translate before, but definitely was headroom that we wanted to address. And when you look at context MT compared to baseline MT, you do get some improvements, so it is a good thing to do, but you don't get all of the way there. For example, like for pro-drop feminine, which is when you drop a she pronoun, you only get about F1 score of 50% if you try this trick of training an MT system with extended context. So at the time, BERT was new. It was brand new. And I think we're in the process of releasing it. And I was working with the authors of that to understand whether it could be fine-tuned for the tasks that I gathered data for. And they suggested another baseline that would be interesting, where it's just called BERT language modeling. And what we do there is we put a mask into the Spanish, like for example, just before a verb that has its subject dropped. So that's in the star at quiero fama. You put a mask there and you ask BERT what word should fill that mask position. And I just looked whether A or L was more probable and picked the one that was more probable. So this baseline actually does pretty respectably, especially compared to something, a baseline MT system, which was trained specifically for machine translation. BERT is just general language representations. But it takes the F1 score from something like 30 for feminine pro-drop to over 50. And if you show the BERT language model extra context, you can actually get pretty comparable performance to the masculine in the feminine. So this is the hard baseline to beat. This is like state-of-the-art language technology, and this is what we wanted to beat. And the hope was that the data that we produced would help us beat it. And it did. So instead of just using BERT as a language model, we did a fine-tuning step where you produce the gender tags based on the data that we just extracted, and we get 90% F1 score, which is what we consider to be kind of like the threshold cap, but that's how clean we think the data is that comes out of our pipeline, based on just getting some humans to vet the examples. So this is what some researchers might cheekily call a solved task using BERT. BERT can learn this task as well, as good as the data it sees. Yeah, so BERT context is just the BERT language model where you mask out a pronoun and ask it to fill in the blank. And so BERT contexts is you show it context. So you show it 2 or 3 sentences and there's one mask position and you ask BERT what goes in that one mask position. So there's no extra data in that. That's just standard BERT that you would download from Google AI and just put mask positions and ask BERT to fill it. BERT context plus data is a fine-tuned BERT classifier. So you download BERT from wherever you get it, and then you feed in the data from our pipeline as fine-tuning data, and then that fine-tuned classifier reproduces gender tags with 90% accuracy, our F1 score. Yeah. So yeah, for our group, this was like one of the blow away, like, oh my God, BERT is going to change the world. Like it can do this so well, like so much better than like models that are trained specifically to do this. The equal performance by gender, even BERT language model had a smaller gap between gender than the MT system did. So it seemed like it was generalizing better than our skeptic brain might have thought. Like it was pretty okay. There wasn't so much gender gap. And then definitely when you fine-tuned it, it was pretty much indistinguishable, like different precision and recall, but that was all. But yeah, so I like to put this. It's like these are awesome numbers. We like numbers close to 100. But even if we can do this task of given a context, can we produce the gender tag? Does it actually help machine translation? And this is what you would consider to be a disappointing result if you just looked at it in isolation. Like you measure machine translation quality just using blue. And if you put gender tags into the baseline MT model, you do get a blue score improvement, but it's pretty modest. I've put alongside the modest blue score improvement what the quality, how accurate the pronouns were, and you do see that the recall on feminine pronouns increases. So you might expect this small blue score improvement humans would rate was pretty important, but it's hard to see in the numbers that this was a really great thing to do. But I believe Melvin and his team got special data sets that had a lot of pronouns, and they broke the metrics down and saw that they were really produced much better. It was just that these sorts of academic evaluation metrics just hid the improvements.
Sydney NLP asked, do you have any thoughts about checking the performance of subpopulations of your task in this kind of setting? I loved this question, and one thing that we did so that we would be able to do this sort of analysis is keep the Wikipedia URL with the example. So if we looked up the URL in the knowledge graph, we'd be able to get what sort of article this is, maybe if it's about entertainment, it's different to about politics, and disaggregate that way. So that was what we did with the data set that we had. I think subpopulations, when you work at Google, you instantly think about whether different slices of your user base see improvements. That's something that is possible now that this has been launched in Translate, but because it's been launched pretty recently, we don't have enough data to know whether different user groups saw more or less benefit from it.
Okay, thanks. That was actually me. There's a couple other questions we've got at the moment. One is from Trevor Kong.
Thanks. Yeah, no, it was a really interesting talk. Thanks very much, by the way. I was just wondering, yeah, so if you do have input texts that are ambiguous with respect to gender, and perhaps this has been done intentionally, they weren't, the person or the original text wasn't trying to invoke either gender. Maybe they're trying to use, say, the word doctor, and they're trying to do it in a generic way without invoking the gender. what do you do in that case, or how do you detect these cases? I imagine the pipeline that you've described, where you use BERT and so forth, you're trying to produce a binary output, and you're trying to then use that in translation. But yeah, how will you deal with these cases where it should be kept ambiguous?
Yeah, that's really insightful, because that was exactly the next stage of the work after it went from being a research project into something that was being put into Translate. It really depends on the genre. Like Wikipedia, often when you go a couple of sentences back, you can resolve what gender something is. So it wasn't something that was important for the research, but when people are able to put in input and potentially, like you say, like intentionally say that the gender isn't there, what the product should do is also reflect that there's no disambiguation possible, and produce both genders. Incidentally, the WMT cooperative, if you, as you'll know it, that's why the blue score is gain isn't as big. It's because quite often there isn't disambiguating context before the sentence to be able to use this classifier as trained. So yeah, from a research setting, it would be redefine the task so you can tell when a sentence is able to be disambiguated and when it's not. And then for a product, make sure you reflect that in what you print out. And that's exactly what Translate did. They just opt to kind of say that the sentences is still ambiguous, and we want to put the two forms there.
Cool. Yeah, I had another little question, if I can sneak one in. So your examples where you had two potential genders and you showed that in the interface, say, you know, here's output 1, here's output 2. But what happens if you have a sentence that's sort of 50 words long and has, you know, 10 instances of ambiguity? I assure you don't present to the power of 10 different translation options.
Yeah, that is actually like the number one thing that is stopping the Translate team being able to scale out the work more than they are. So they want to be useful to their users, but that isn't showing 50 different options for how to translate a sentence. So it only does it if there's a single entity and that entity is ambiguous with respect to gender, because then you have a handful of options to show. They're also considering in the same breath like things like politeness, and how do you show like the TV forms in Romance languages. They don't want to have to like do genders plus politeness plus all of this. So their research in this direction is changing from being core NLP research to UX research. And they've got some pretty cool stuff about what do users actually want to see and when is it useful to have a branching point and show multiple options. But yeah, about the sentences that mentioned 50 different people, it's just that never makes it through the filters, so we can't do anything with them just yet.
Yeah, no, that makes sense.
We do also have a question from Ian Wood, who's still around. Half a second. Ian, go ahead.
I was just wondering, when you're selecting the context, I imagine situations where, like if you have a sentence about the husband of Marie Curie embedded in the web page about Marie Curie, and then there might be some gender ambiguous references to him. How do you sort out the context, like in your data set, and then how does the model sort that out, which is the appropriate context?
So yeah, a great question. That is something that we actually followed up with a little bit in the paper, but even more internally. We did all this visualization of the model to make sure that when there are multiple people mentioned in one pronoun, that the attention weights actually were centered on the coreferential mention and not the distractor mention. So obviously the model could make mistakes and say, I'm going to look at husband when producing this pronoun, but almost always it actually put all the attention weight on the coreferential, like her rather than husband. But it's not separated in the data set. That was just something we did internally for quality assurance to make sure the models were actually doing the right thing for the right reason. But yeah, they're pretty smart, unfortunately or fortunately.
That's something that's, sorry, go ahead.
No, I was just saying fortunately. But
Yeah. I'm just going to like go off on a small tangent because I think a few of these questions have touched on it a little bit and I've like kind of not even addressed it, is what to do with when the information present is someone's name rather than a gendered word like husband or her. And a lot of the thought around that is that like people should be able to opt for their own gender, regardless of whether they have a gendered name or not. And that's partly why we picked Wikipedia, because we're able to trace through what someone's reported gender is. But when you move to community translations, then that's something that becomes important as well.
Something that's maybe a bit of a follow-up as well on Ian's question, which is, you said that the performance currently is capped by the data. So are there things that you're doing to improve the data, or are we good enough now?
So this was good enough for the research paper. Obviously, Translate has a huge amount of data beyond Wikipedia that you're able to do this to, and that's how they ended up launching it. And there, it's a question of data selection to get precision recall balance that you want.
Thanks, Kelly. And maybe if I can just sneak in another quick one. I mean, so part of the problem here is evaluation as well, right? And the way the tasks have been framed by the research community in the past. Are there easy things that the research community or that the task, you know, and when we're designing these kinds of tasks that we could do to make this sort of represented in the tasks and the data and weighted appropriately?
Yeah, I don't think the community did anything wrong. Like when WMT was first proposed, like it was proposed as such a challenge that it actually took a very long time for machines to be able to do it. It's just unfortunate that right now we're at this like a changeover point where we're able to do this thing that we thought was you know, too hard for a machine to do, and we're kind of having to use our imagination a bit to extend beyond that. But so what always guides, like when we're like where our group is investing a lot in data sets, and that you can see that like our group has released a lot of data sets. We always just try to follow like what users ask us for. And so we did this project because a lot of users were filing bugs saying that the pronouns were always wrong and it was really jarring. So if the user feedback is about some other phenomena, that is what we'll make a data set for and try to improve on.
Very cool. It's a crossover to UX kind of again. Are there references for the UX work? Are there any blogs or papers on that stuff, or is that really internal product kind of stuff?
At the moment, that is a completely internal product, but Translate is like the team that wants everything to be public. So I'm sure if there was interest, they'd be able to make some of that public. I haven't. That's really interesting. Yeah, they really want to release as much as possible. Yeah.
Cool. Thanks, Kelly.
Okay, should we get the show rolling again?
So I think we have a few sort of spotlights on different things the team has been looking at. So I'm just going to use a few slides for a few different projects that I think is interesting, might be interesting to you as well. So one thing we're thinking about is we have this approach that Kelly described which is trying to address gender bias at the document level, right? But there are other phenomena at the document level that also need to be addressed. So one of the things that we're thinking about is how do we do end-to-end document level translation? So we're looking at a few approaches here. So one is a approaches that use larger context. So the most common ones are the concatenation-based approaches that you might have seen from Tiedemann and a bunch of other papers. So they do either many-to-one translation or many-to-many, right? So many-to-one means you have 3 sentences on the source, the 2 sentences are context, and you only translate the third sentence. Many-to-many could mean you have 3 sentences on the source, and then you produce 3 translations in the target. There are also these 2-pass approaches. A very popular paper is monolingual post-editing. This is a paper from Elena Wojta, where they take a chunk of outputs from the sentence level system and they post-edit that chunk into a more consistent output. And they find that doing this post-editing or second pass step actually helps with contextual phenomena. There's also some variants of this. You can do contextual post-editing with some source side context or target side context or both source and target side context. Again, the goal is you have some outputs from a sentence level translation system. You have some context at the document level. Can you encode the context and the sentence level translation to produce a better translation? There are a bunch of open questions with document translation. So Kelly, if you go to the next slide. So one of the big problems that we have is finding high quality document level parallel data. We all know and we're used to these WMT data sets that are at the sentence level, but when you actually try to find high quality document level parallel data, there's not a lot of high quality data. So this is a big challenge, is how can you find good high quality document level parallel data? The other open question that we're trying to look at is, can we leverage different pre-training objectives to do better document level understanding? So we know BERT style pre-training is very effective at the sentence level. So you're given sentences and you mask certain words, and the model has an understanding of natural language. Can we have similar pre-training objectives that have document level understanding? A good example of this is if you've seen the BART paper or the MBART paper, they have an objective that takes sentences in a document, it shuffles the sentences, and then in the decoder, they have to produce the sentences in the right order. So this is just one example of a pre-training objective that could be better for document level translation. And the third, I think it's a very important question is, when and what kind and how much context is useful and relevant, right? Most of the time, sentences are independent. They can be translated correctly without any context. And some of the time, they actually need the context to produce the right translation. So there's this big difference between 90% of the time the context is not relevant, but 10% of the time the context is extremely relevant. So how do you force the model to learn when the context is useful, or how do you know when the context is useful and how much context is useful? So these are big open questions that we're trying to look at. And finally, as Kelly mentioned, evaluation of these contextual systems is a big problem. So Blue score is not very sensitive to these contextual phenomena. If you looked at the results from Kelly, she gets a 0.1 increase in Blue, but a big increase in gender accuracy. So we need these other metrics like pronoun accuracy or lexical cohesion metrics or consistency of entities to measure some contextual phenomena in addition to using Blue score. Next slide, Kelly. Yeah, so this is another interesting project about gender-neutral language in translation. So this was work done by our intern, Tony, and Kelly and Apu on our team. We co-hosted Tony. So I showed you this example at the beginning of the talk where when we get this Turkish example, we now produce 2 translations, right? A masculine and a feminine one. But what if we also produced a neutral translation? They are a doctor in this case, right? So the goal of the project was, can we actually take a gendered sentence in English and rewrite it into a gender neutral sentence? The next slide. Yeah, so that, as I was just telling you, the goal is to rewrite gendered sentences in English to gender neutral sentences using singular they. And we tried to restrict the domain of the problems that we wanted to tackle. We only picked sentences that had a single gendered entity. So here is an example. He finds his way to a bar stool and orders a drink. We want to change this to they find their way to a bar stool and order a drink. If a sentence has two entities, then we don't want to rewrite it. So, for instance, he spoke to her. We don't want to rewrite that to they spoke to them, because both the they and the them are ambiguous and it's not adding a lot of value. So we only restricted ourselves to the single entity case. Next slide, Kelly. So our approach is pretty simple. So we took an initial data set of about 100 million sentences from Wikipedia. We filtered out sentences that were gendered. So out of the 100 million, about 15% of them were gendered. We had a rule-based algorithm that we took these gendered sentences and rewrote them into gender-neutral variants. And for the algorithm, it was a bunch of rules. So we know that he and she can be written to they. We also used the dependency parse to change the verbs, right? So he is a doctor, it has to become they are a doctor. So we use the dependency parse to find that is the verb, and then we change the verb to the, we pluralize the verb, so we change it to are. We also use a language model to break ties between different alternatives. So basically, a whole bunch of rules using a dependency parser and a language model to create a data set. So now we have this parallel data that goes from gendered sentences to gender neutral sentences. Can we throw all of this parallel data into a sequence to sequence model, and we train an MT system that's translating from gendered language to gender neutral language? And that's what we ended up doing in this project. So the next slide, we have some results. So we took about 500 out of domain sentences. And if you produce the identity, we try to measure blue score and word error rate. You can see row number 2 is our algorithm, the rule-based algorithm. It gets a pretty high blue score because most of the words are the same, right? The only things that change are the pronouns and the verbs. The word error rate is also pretty low. And the sequence-to-sequence model that we train is pretty good. It's pretty similar to the algorithm, 99.4 in terms of blue score, a little bit higher word error rate. But when we actually looked at the errors of the system, so on the left, you see the distribution of mistakes that the algorithm makes. A lot of the mistakes are with respect to masculine pronouns, feminine pronouns, auxiliary verbs, and root verbs, and some mistakes when it comes to symbols and negation. Whereas if you look at the model, even though it has a low blue score, a lower blue score and a lower word error rate, the number of mistakes that it makes with respect to pronouns and verbs is much smaller. A lot of the mistakes that it ends up making is the sequence-to-sequence model cannot produce the same smiley that's on the source side, or it cannot produce the same symbol, the hashtag that's on the source side. Sometimes it inserts a white space and things like that. So these are all like robustness issues that we know about sequence-to-sequence models. But basically, this was an interesting sort of fun intern project. So can we build a translation system that goes from gendered language to gender neutral language? And if so, how good can it be? And the results are telling us that it's pretty good, it's possible, and we're sort of excited about this direction of work, and it can be useful in many different scenarios, right? Not just translation. So one application that I can think of is when someone's writing a job description, if the job description is gendered, we can apply this rewriter and rewrite the job description to be gender neutral. Or if you're using Gmail and Smart Reply is giving you a suggestion, if it's giving you a gendered suggestion, we can apply this rewriter to make it into a gender neutral suggestion. So a bunch of applications for this kind of work. I think that was the end of our talk.
Okay, one last round for people to ask questions. I see we've still got a fair few people who are watching. I wonder if any of you have got any questions you'd like to ask. Trevor Cohn, hang on. Off you go. You'll need to unmute yourself.
Sure, thanks. I was just wondering about the cost of making mistakes, I guess the social cost of making mistakes. So for instance, you know, I mean, you've considered a lot of cases where it's, you know, ambiguous as to the gender on the input, and then you're committing to a certain gender in the output, potentially, or at the end trying to keep it ambiguous, say. But I guess also any change you make, you might also be changing cases where there is a stated gender on the input and you end up changing it to the wrong gender on the output, say. So I'm thinking, yeah, implicitly there's some kind of cost matrix about all the different types of inputs, all the different types of outputs you produce, and, you know, Google looking bad for being biased, for instance, or people getting grumpy about Google changing the data to something that they didn't intend and making work for them. So yeah, I wonder if you had any thoughts about this aspect.
Yeah, my thoughts are that is absolutely the hardest thing here, and why things move a bit slower than people would like to see them move. So there's a lot of great academic research about how to handle gender in Translate, and there's a lot of obvious cases where where Google isn't producing the translation that someone would like it to produce. But there's a lot of factors to consider, including at the moment we can state exactly what we're doing. We can state exactly what data we're using. Everything is traceable, and we know why we're making a mistake if we're making a mistake. And be able to be accountable to users in that way. So accountability to users is like one of the core principles that we try to follow. If we start changing things too much, we can't sacrifice that accountability. So we need to make improvements while keeping all of that in place. And it's an open challenge and something that is considered in every stage of the approvals for any release that we have. There's a lot of evaluation that goes on internally before we can release something. So the example is I'd finished this work, this research work, and it took a year to get into the product because I went through all sorts of audits to make sure that we weren't, that we were being socially beneficial, and we were still accountable.
Okay, so a lot of the test sets are then going to be testing to make sure that you're not having these side effects on other translation results that you hadn't intended.
Exactly.
Okay.
Yeah. It's good. It's good that it's so hard, but it is the number one reason why things change in products slower than people would like them to change.
Yeah. Thank you.
I see a question from Chatia.
Hey, yeah, thank you.
Okay.
I was just wondering, how do you see Google leading inclusiveness when it comes to gender pronouns for, like non-binary people, people who identify as a different gender to their birth sex, etc.
Yeah, this one again is something that I'm most comfortable with. The saying is like, if you don't include someone in the room, then their voice isn't heard. Like I am not part of this community, but I'm very supportive of it, and I know we actively seek out the advice from different Googlers who have more humanities style backgrounds into gender studies and are active members of these communities for how to do the research in these directions in a really respectful way. So I know Google 100% is wanting to lead research into these areas, and one of the blockers that we're facing is the availability of data sets that accurately represent these groups, and we don't want to create that ourselves because we don't want to be the authority of what represents this community. But I think what needs to happen so that everyone can do research in these directions is for some community-led data sets, challenge tasks, maybe like statements, like statement papers saying like this is what the future needs to look like. I'm not sure that we'll see a company leading it, because I think a company doesn't represent that group. But I can definitely see Google wanting to research this if there was the right tasks and the right data sets to explore. I think I'm thinking of the Jigsaw team, which is within Google. They do the toxicity classification task, and it's particularly aimed at like when people are being toxic towards different groups. And they found sparse data for a lot of the different groups that they wanted to consider. And the way that they addressed that was by engaging those groups to create more data that truly reflected the character of those groups. So I hope that answers it. It doesn't really.
No, that's a, I did answer it. I think you're right. When it comes to any kind of communities, it's always good to research and have the voice of the people from that community to input. Yeah.
Yeah,
thank you.
Kellie, I guess following up on that a little bit, is that something that's sort of part of the scope or the goals of the gender bias workshop as well? I mean, is there a role for the workshop to try and produce some of these data sets? I mean, I know you have shared tasks or challenges as well. But.
Yeah, we are actively seeking someone to lead the shared task for next year, and I can help them, having led a shared task in the past. So if anyone is interested in setting up a shared task with anything to do with gender and NLP, please reach out to me. And I'm happy to support you to do that. I think the way that Google supports these sorts of efforts isn't by Googlers doing projects, it's by like partnering with different institutions. So like we have partnerships in the US with a lot of the key universities who have people on staff who are experts in these directions, and we can absolutely use the gender bias workshop as a partnership like that.
So I guess on that note, we'll thank you very much for a very interesting talk, Kellie. Thanks for taking time out of what I'm sure is a busy evening and making yourself available to answer a few questions on the subject. It's really interesting to actually see this field move forward, because language, of course, is just like a massive pile of compromises and contradictions. So trying to figure out how to get computers to do anything with it, let alone sanely, is, of course, quite a lot of fun to think about. So thank you again.
No, thank you. This has been fantastic. Thanks for the engaging questions.